Hello everyone. In today's session, I'll be running all the load multiple and store multiple instructions associated with stack operations. Okay, so let me just first check for errors. There are no errors here. So let me start the debugging. Fine. The very first instruction I have used is a sudo instruction. I'm loading a 32-bit value for all zeros and 14 into the register R13 because R13 itself is my stack pointer. Okay. So what I'm trying to do is I want all these load store operations to be carried out starting from this particular memory location. So these four instructions are just used to store large 32-bit values into registers R1, R2, R3 and R4. So let's just execute this. So all registers R1, R2, R3, R4 along with a stack pointer, okay, everything is updated with new values. Initially stack pointer value was 0, okay. So now let's just continue with our actual instruction. So what is happening here is store multiple full descending. Okay, this is my instruction. Okay, and if you notice here, I have not used an exclamatory mark, while here I have used an exclamatory mark. So what will be the difference? Same operation will be carried out in both the cases, just that here the stack pointer won't be updated, here it will be updated. Okay, and which register content I'm trying to store? I'm trying to store content R1 to R4. Okay, and what is this STMDB? I know whenever STMFD is specified internally, store multiple decrement before operation is carried out. Just to make it easier to understand, I have specified it here. Okay, so what should happen in this particular case? Where is your SP pointing at? SP is pointing at the location 4000 and 14. Okay, so what is that location? So this location is 4 all zeros and 4. So this one will be 8. This one will be 4 all zeros and C. This one will be 4 all zeros and 1 0. And this one will be 4 all zeros and 1 4. So currently this is the location where SP is pointing. Okay, and what I want to do is I want to store these values. If you are confused with what happens in case of full descending, we can see it is nothing but decrement before. What it means, don't store value here, decrement, start storing value here. So the one value will be stored here, one over here, one over here and one over here. Okay, those are the four values, R1, R2, R3, R4. Next question is, which among this should be placed in each of this location? We know one concept that you should always consider the order or suffix of the registers. Whichever has higher order will be placed in higher memory location. That is, this location will be filled with R4, this will be filled with R3, this will be filled with R2 and this will be filled with R1. So this is the result we are expecting. Let's see if that happens. So if you notice here, what was R1 content? It was this 1, 2, 3, 4, 5, 6, 7, 8. It is placed here. R2 content is placed here. R3 content is placed here and R4 content is placed here. And you can see SP value remains same. It is not updated. And one more thing you see is nothing but the value 1, 2, 3, 4, 5, 6, 7, 8 is placed as 7, 8, 5, 6, 3, 4, 1, 2. That is because of Little Indian concept. Okay, so this was our very first instruction. So what happens next? Next is same instruction if you execute with an exclamatory mark after your stack pointer. What happens then? Because previously exclamatory mark was not there, it clearly meant don't update ESP. So ESP is still pointing at the same location. And what should happen if in this instruction you are updating it? The positions where data is filled remain same, just that stack pointer will now point to this particular location. So the position shown here will be the position where SP will be pointing, that is 4 all zeros and 4. Okay, so let's see if that is the case. Yes. Is there any other change in the memory location? No. You can see same values are there, just ESP got updated, or in other words, R13 register got updated. Okay. So next what we have is nothing but LDMEFD, which is nothing but load multiple full descending, and we know internally it is nothing but load multiple increment after. So what it means is this particular content, okay, should be loaded into one of this register, then increment to next position, load this into the register, then increment to this position, load this, increment here, load it, but it is increment after, so ESP will be pointing at this particular location. Okay, now we know these values should be loaded, but into which registers? It is R5 to R8. Among these registers, the register with lowest order is R5. So R5 will get this content, then it is R6, then it is R7, then it is R8. And what value will be stored in stack pointer? For that, just check the first term. This will be 4, then this will be 8, because after 4 location it is 8. This will be C, this will be 1 0. And what is this position? 1 4 or 4 0 0 1 4. Let's see if that is true. As you can notice here, R5 got this value, R6, R7, R8 have received the appropriate values. At the same time, what happens to stack pointer? You have received the value 4, all zeros and 1 4. Okay. Now let us go to our next instruction. Now this is the current position of your stack pointer. That is one thing you should know. Next what we have is nothing but we are again loading new set of values to R1, R2, R3, R4. Okay, you can use any general purpose register here, but just for my convenience I have just repeated using same registers everywhere. Okay, so now let's just continue. We have new set of values to be updated to R1, R2, R3, R4. Let's see that happen. Okay, so we have updated all 4 registers. Next instruction we have is store multiple full ascending. Okay, and if you notice here, it is nothing but store multiple increment before. That's why first we will move to the next higher location, and then we start storing the data. Which register contents are we storing? R1, R2, R3 and R4. As already informed, this content will be placed first because that will be the lower address compared to all next memory locations. Okay, so now R1 content, where I'll start placing it? Here. So this is where R1 will be placed, this is where R2 will be placed, this is where R3 will be placed, and this is where R4 will be placed. And what happens to your stack pointer? Because it is increment before, okay, it is increment before loading. So this is the first, second, third, fourth. So this is the location where your stack pointer will be pointing at. This location will be nothing but 4 0 0 0 0 2 4. Let's see if that is true. Yes, we got the same value updated in stack pointer. And what happened to these values? R1 value is updated here. What is R1? 3434. Okay, R2 is over here, R3 as shown here is updated here. Okay, and stack pointer got updated as expected. What is the next thing that should happen? Next thing that we have is nothing but your load multiple full ascending, which is nothing but load multiple decrement after, which means currently whichever location stack pointer is pointing at, okay, first load that data and place it into the concerned register. Okay. So here what is happening is we want to load these contents into registers R5, R6, R7, R8. Okay, we have SP currently pointing at this particular memory location. It is decrement after, that is decrement after loading. It means this particular content should first be placed in register R8. After that, decrement this so will be loaded into register R7, this into R6 and this into R5. It is decrement after, so it means that this is the position where your stack pointer is supposed to be pointing at after this particular instruction is executed. And what is this location? This is nothing but 4 R0014. Okay, let's see if that is true. Okay, done. Next we are again loading with new values for R1 to R4. Let's update them. Okay, so our instruction that we have next is nothing but empty ascending, and we know empty ascending is nothing but increment after. So what does that mean? Currently SP is pointing here. We can know that just by looking at R13 content. Okay, so what should happen is increment after storing the data. Which data are we speaking about? Content of R1, R2, R3 and R4. First, among these we know this has the lowest order, so R1 content should be placed. It's increment after storing, so store the first content here, next content here, then it is here and then it is here. Okay, and then the stack pointer should be pointing at the next location, which is this place. Okay, so which content should be placed here? R1, here R2, R3 and R4. Okay, so what is R1 content? It is all 8s. Let's see whether this is how it is working. As you can notice here, R1 content is updated here, R2 is over here, R3 over here and R4 over here. Okay, and where exactly your stack pointer is pointing at? It's exactly this particular spot. Next we have load operation, LDMIA, that is load multiple empty ascending. Internally it is nothing but load multiple decrement before. What do you mean by decrement before? First decrement to this position, okay, that is this position, and then start loading the data. Which data are we speaking about? We have registers R5, R6, R7, R8. So among this, we already know R8 should be chosen at first. So this particular location content should be copied to R8, R7, R6, R5. And what happens to stack pointer? It will be pointing at this location, which is 4 all zeros and 0014. Let's see if that is true. Yes. Okay. So next we are updating the new values for R1, R2, R3, R4. Okay, so new values are updated here as expected. And the last category out of the four different stack model is empty descending. So what is empty descending? It is nothing but decrement after. So what is decrement after? This is the position initially pointed by the stack pointer. First update this particular location. Okay, we have register R1, R2, R3, R4. It's decrement after, so we know we are moving to lower memory addresses. So first update this with R4, this with R3, this with R2 and this with R1. Okay, and what happens to stack pointer? It will be pointing at this location, which is 4 all zeros and 4. Let's see if that is true. Yes. Okay, so where exactly the stack pointer is pointing? It is at this location. And next what we have is nothing but load operation, wherein register R5 to R8 are involved. Okay, so we know this is nothing but increment before. It means forget what is stored here. Okay, first increment to next location, which is over here. Start loading data from this position. This will be the first content R5, this will be R6, this will be R7 and this will be R8. Stack pointer will be pointing at this location. This is nothing but 4 all zeros and 1 4. Let's see if that is true. Yes. Okay, so next I think we have finished all stack models. Just I wanted to show even how push pop operation works. Okay, these are nothing but pseudo instructions which work internally same as store multiple full descending case, that is they get converted to store multiple decrement before. Okay, so let's see how it works here. Before that, let's just load the new values into R1 to R4. Okay, now they are updated. Now we'll perform push operation. So first thing you should know, where is stack pointer? As per this, stack pointer is pointing at this location. This is where your stack pointer is pointing, and I want to perform decrement before. What is decrement before? Forget this particular location. Move to the next location, that is this location, and start storing the data. So here you will store your value of R4, here R3, here R2, and here R1. Okay, and because it is decrement before, this is the exact location where the SP will be pointing after this particular operation. Okay, so let's see if that is the case or not. Okay, so last thing what we have is pop operation, which is nothing but LDMFD, or in other words LDMIA. So what should happen here? It's increment after, that is increment after loading. Load the first value into which particular register? R5, this R6, R7, R8, and the stack pointer should be pointing at this particular location. Okay, and what is this location? For all zeros and 1 4. Let's see if that is the case. Yes, those are a few things you needed to know in case of LDM STM instructions used for stack operations.